So let me solve the first one, and I'll give you some time to think about the second one. So here is when you make use of the skills that you just learned, putting a bunch of logs together into one, okay? So you put this together, what do you get? You get log 2 of? Very good. Now, since you're trying to solve for x, you want to get rid of log base 2. And, well, we learned two cancellation laws last Monday, but we've only been using one kind of cancellation laws. So let me tell you what I mean. So we've been doing a lot of the log base a of x cancels to x. We were using this a lot today, right? But there's another type of cancellation law where it says a to the log base a of x cancels like this, and you get x. Okay, so these two were the fundamental property of the log. You can even say, if somebody asks what a log is, you can just answer saying that it's something that satisfies two cancellation laws against the exponential function. That's what log is. Okay. So what you do is you're going to take this and exponentiate both sides over 2. Like that. Okay. And if you do that, the equal sign will be still preserved. See, it's like this. You have identical twins, and you give them the same food, same clothes, same education, and when they grow up, they get the exact same job, right? Well, it doesn't work like that in real life, but in math, it does, okay? So if you have something that are equal, and if you treat both sides exactly the same way, the equal sign is preserved. And then we can continue to solve it. Yeah. So we can cancel these and get x plus 1 times x plus 5 equals to 5. All right, and then this is x times x squared, x times 5, 5x, 1 times x, 1 times 5 equals to 5. So x squared plus 6x. Oh, sorry, that's not right. 2 to the 5. What's 2 to the 5? 32. Right. I knew something was wrong. So it's this, and then you subtract 32, both sides, and you get x squared plus 6x minus 5 minus 32 is negative 27. Now think of two numbers that multiply to negative 27 and adds up to 6. What are those two numbers? Negative 3 and 9, yes. So you have x plus 9 times x minus 3. Because 9 times negative 3 is negative 27. 9 plus negative 3 is 6. And then we solve this to get x plus 9 equal to 0, x minus 3 equal to 0. We get x equals to negative 9, x equals to 3. So it seems like you have two answers, but wait. One of them doesn't work. Which one? Negative 9 doesn't work, and the reason is if you try the negative 9, you plug it into the original one, you'll see right away that negative 9 plus 1 gives you negative 8, and you can't have a negative inside the log. So domain of log is only positive numbers. You can't plug in 0, you can't plug in negative inside the log. Okay? So when you get an answer that makes the inside of the log negative, immediately that will be a illegal answer. Okay? So if you want to check this with your calculator, you can take your scientific calculator and do something like ln of negative 2. Just put that in. You'll immediately see that it gives you a domain error. Yeah. Yes?
This is what we did yesterday at our station.
Yes. Okay, so that's not going to work. But this is fine. X equals to 3 is fine. You can plug in 3 here and here, and both of them are positive, so perfectly fine. Okay, let me just make one more comment. Over here, since we were able to get rid of log 2 by putting it over 2, why didn't we do it here, 2, 2, 2? Would that be a possibility? Does it make it easier? Is this okay? Can you put 2, 2, 2 here? The answer is no, because you're not treating both sides the same way. See, I wrote 2 twice on the left side. I wrote 2 once on the right side. Are we treating the two sides in an equal way? No, it's not. So that's why that's illegal. But that's fine. Yeah. Yes, you have a question?
Might be a stupid question. Why did you choose to do a base of 2 instead of like any other number? Is it because the log was 2?
No, the log base 2. Oh, yeah. So the question has log base 2. Therefore, you want to raise it over 2 so that they can cancel. All right. Okay.
So it just has to match whatever log.
Right. So just to make a little bit more point about this is that if you have 1 plus 2, you get 3, of course. That's easy. Now, is it true that the equal sign still gets preserved if I put 2 under? Is this right?
No.
No, it's not. 2 to the first power is 2. 2 squared is 4. 2 plus 4 is 6. And that's not the same as 8. So this is not true. So if you put 2 under like this in individual terms, you don't preserve the equality, so you can't continue to solve it. But if you put 2 just once like this one and this one, then the equality still gets preserved, and that's why you can continue to solve it. That's the important part, okay? That's why it's important to be able to combine different logs into a single thing. All right, so think about this one. What do we do? How do you get rid of log base 3? Put it over 3 so that these two cancel and you get x plus 4 over x plus 10. And what is 3 to the negative 1 power? It's 1 over 3 to the first power, right? Any negative power means you flip over, right? It's 1 over. So it's 1 over 3 to the first power, which is 3 to the first power is 3. So this is what you get. Now you have an equation with fractions. How do you handle equations with fractions?
Kill the denominator.
Kill the denominator. Yes, I need that stern. Kill. Yeah, you want to kill the x plus 10. You kill the 3. How? You multiply both sides by x plus 10 and also by 3. X plus 10 and also by 3. So that 3 and 3 will cancel away, and x plus 10 and x plus 10 will cancel away. If you do that, you get 3 times x plus 4 equals to x plus 10. And then that's 3x plus 12 equals to x plus 10. Let's subtract x both sides. Subtract 10 both sides. And you end up with, actually, let's subtract 12 both sides. Yeah. So if you do that, then this will become 12 minus 12, 2x, sorry. 3x minus x is 2x, and 12 minus 12 is 0. X minus x is 0. 10 minus 12 is negative 2. And now you divide both sides by 2. You get negative 1. Okay. Is negative 1 an answer?
No.
Why not?
You can't put a negative in the log.
Well, the answer is yes, it is an answer, because if you plug in negative 1, negative 1 plus 4 is positive 3, so it's fine. Negative 1 plus 10 is positive 9, so it's fine. So it doesn't have any trouble with the domains. There is no domain error with x equals to negative 1, so that is an answer. So the answer for this second question is x equals to negative 1. Okay, last question for today. This is a rather challenging question. And the big problem here is that this 2 is inside the log, right? It's the exponent inside the log. That is allowed to jump over the log. Okay, so 2 would jump over the log, and you get 2 times log of x. By the way, if you don't see anything under, what does that mean? Base 10. Okay, so it's really base 10 over there. But see, this squared is not inside the log, therefore this is not the one that jumps over it. Only when you have the number in here or there, they can jump both ways, okay? So you can't do anything about this one. Yeah, so we just leave it, okay? So you're stuck right here, and the only way to proceed at this moment is to do substitution. So let's try to do substitution. See, I see log base 10x here, log base 10x here, so I'm going to say t is log base 10 of x. Okay, that means this equation now becomes what? 2 times t equals to t squared. Okay, how do you solve this? Okay, I guess one way to say it is like you divide both sides by t and you get t equals to 2. However, that's going to miss one solution, okay? You shouldn't do that because t could be 0. Okay? So it's either t is 0 or t is 2. That's the correct one. The better way to solve this is to move this to the other side, and you get 0 equals to t squared minus 2t. Now, what can you do with this? You can factor a t, right? And that gives you t minus 2. T times t minus 2 does give you t squared minus 2t. Therefore, when you solve, you get t equals to 0 or t minus 2 equals to 0. This one further says t is 2. Okay, so I get t equal to 0 and t equals to 2. Are we done? Did we solve it?
Oh,
Why not?
because you gotta figure out which answer works.
No, not that. Not that. You have to go back to x. See, the original question is asking for the value of x, right? We only got the value of t. So now we have to replace the t by log base 10 of x. So we really have log base 10 of x equals to 0, or log base 10 of x equals to 2. Okay? Now how do you solve this? That's 1. Why is it 1? Okay, so that's log 10 of 1, and log a of 1 is 0. So that's a quick way to know, but you could also raise both sides over 1 so that these cancel, which gives you x equals to 10 to the 0th power. Anything to the 0th power is 1. Okay? So, good. How about this one? 100, yes. Log, you raise both sides over 10 so that they cancel, and you get x equals to 10 squared. 10 squared means 10 times 10, which is 100, okay? And then, again, if you check with this, 100 or 1, both of them are okay because it's positive. So none of them has any domain problem. So that's the answer. Those are the answers. 2 answers.